from our math workshops. There are 2 of these problems that I ought to skip, but I'm not going to. If you can tell me why and which 2, I'll give you 3 points. Say it again.
12 because it's a degree. 10.
It's 10 and 12, but she said all the words right. So I'm going to give her 2 out of the 3 points. So we're not going to skip, but if it's on the test, this one would not be, and this one would not be. Now let me rephrase. While you would not have to graph them on the test, you might have a problem like this that's high in degree that you have to still state the zeros, degree, and the sign of the leading coefficient. You still might have to do all that. You just won't have to graph degree 5 or higher. Okay, I'm just going to start with number 12. Let's start with 12. I need to know the zeros. 5 gets the point. Didn't even ask the question, and you can have a point for that. Since it has a multiplicity of 3, does anything fun happen at that point? No. Only the even multiplicities have something cool happen. That was 2 and 4 get a point. You have a cool bounce if it's an even multiplicity. It's not. Okay, so we've got our zeros. We still need to know our degree and about that leading coefficient. The degree is 5. Let's see if he's correct. 3, 4, 5. He is correct. You can have a point for that. The grading coefficient is positive, and she was very specific, +1. We really just need to know positive, negative, but specificity is great. Okay, since the degree is 5, what does that tell me about the end behavior? Same direction, different directions. They're in different directions. Since the leading coefficient is a +1, I'm supposed to be thinking about a snake. Is it going up the wall or down the wall? So I know I've got something like this. A snake going up the wall, and then at the end it's going to go the opposite way. That was terrible looking. They got to go the opposite way because the degree is an odd number. And then I know since it's a +1, I'm going to be snake up the wall. So I'm going to guess a little in the middle. But I know it starts off like this. Now maybe it does this. I don't know. Since it's degree 5, it doesn't have to look exactly like that. It might look more like this. I don't know. It could be the pink. It could be the green. It could be something in between. I don't know. If it was degree 5 or higher, again, I would in real life use my graphing calculator. There might be a couple more humps that we're not anticipating. But regardless, did we deal with our end behavior? Did we cross our zeros? Did we at least consider the multiplicity? Yes, we did. Are there any questions about number 12? Then let's go to number 10. Where are my zeros and 0, 4, -2, yes. You got your point. Zeros, and then what degree did you say, Travis? 3, 4, 5, 6. It's not 7. It's Drady's right. It's 8. He said it first. Give him his point. 3, 4, 5, 6, 7, 8. Don't forget about this one. So the degree is 8. And then my leading coefficient is a +2. Okay, so I'm going to go ahead and put my zeros. 0, 4, -2, -3. The degree is an even number, so does that mean my end behaviors are opposite or the same? They're the same, so one step at a time. So either they're both up or they're both down. Are they both up or both down? Both up because it's positive. So we're doing this one, we know, because it's positive. So yes, Travis is right, and there's some other stuff we're about to talk about, but at the end of the day, I know it's going to look like this because the degree is a positive, even number. Okay, and then Travis pointed out the obvious. So before we go crazy and just start trying to connect the dots, I've got to think my life through. Some of these have a multiplicity. Okay, so I'm going to draw some arrows. These two have a multiplicity of 2. Whereas this guy has a multiplicity of 3. Now, sadly, poor multiplicity of 3, he doesn't get to do anything cool. But at 4 and -3, something cool should happen. What is that cool thing? Say it again. Yes, so it's going to have like a bounce, or it looks like a parabola at that point. Now, since it's a degree 8, I don't know that it's necessarily a W or a W. It would have to be W right now, but we don't know that's a W. Degree 4s are specifically W's. We're going to have something a little more complicated. Now, maybe it looks like this. Or maybe it looks like something a little different, but regardless, we better have the correct end behavior. We better cross through the correct zeros, and we better have considered that multiplicity. But again, everyone showed well. 95% showed me their checkpoint on Friday, and eventually we were on the same page with this, so we should be okay. Are there any questions about 10? Now for one that could actually make the test. This one is actually really easy, but it looks pretty hard. Tell me what we already know. Every group can have a point. I already know that. Easy point. Now, if the degree is 2 and the leading coefficient is -2, what letter of the alphabet should this graph look like? And 4 had it first. We know it's a parabola, and we know because it's a negative, it's a sad parabola. So I got to figure out where my zeros are, but regardless, when I connect the dots, it's going to be a sad face or an N or whatever you want to call that. I still need to figure out my zeros, though. How do I figure out my zeros? Okay, I heard the fact. I like that. I heard. Let's give one the point. She was on board. She said it first, but we all jumped on quickly too, so it was very good. We take out a -2. We got this. Because everybody was negative. Okay, so DJ asked the question. Let's make sure he's happy with that. Everybody had a 2, because 2, 12, 16, all divisible by 2. And then since everyone had a negative as well, that's why we just had to take out a -2. And then so we got to this thing inside the parentheses. That was an easy factor, because 4 plus 2 is 6. 4 times 2 is 8. So that was an easy factor. So we're happy. So I know my zeros are... Say it again. And I am so mad at you. No. Thank you, Brady. Point for table 3. Did we factor out a -2x? Didn't we just factor out a -2? So I have a 0 at -4. I have a 0 at -2. I don't have, unless there's an x suddenly right here, I don't have a 0 at 0. I have one at -4 and -2. And then second of all, its degree is 2, right? So at most it had 2 zeros. So why are you telling me 3? At most it had 2 to begin with. Plus, think through what you were saying. If we put the 0 there, and at -2 and -4, how are we going to make a sad face? I don't know. We'd have to pick 2. It has to. That one's wrong. It has to be these 2, and we have to have a sad face through them. And hopefully your sad face looks a little less jankety, because mine got a little rough there on the end. Okay, so moral of this story is You do know what you're doing. You already passed the checkpoint. You've got the end behavior part, the zeros, the multiplicity. You've got it all. I'm not worried about this part. And I'm not actually worried about the next part. All we're practicing today is stuff like this. Because if we can factor, we can figure out the zeros. So that's what our new notes are about. I gave your group some new notes. We're going to be on the very front page. We're going to be on this front page today and tomorrow. All we're wanting to think through is when we factor, we're getting the zeros. The zeros help us graph. Okay, you were smart. You can tell me what word or what it is that goes in that top blank. Okay, and then so which problem should I be concerned about then? 5, 8, and 11. So if I were you, I'd go ahead and circle 5, 8, and 11. Why are we circling 5, 8, and 11? Because they're not set equal to 0. So hopefully we'll get to number 5 today. If not, I won't cry. Let's go ahead and move the 27 over, and then he would be equal to 0. So on 5, 8, and 11, we have to do an extra step because we have to be equal to 0 first. Okay. Let's start with number 1, which is kind of cut off where it punched holes, my bad. It is actually just a squared. Very disappointing, huh? I need to know how to factor that. I don't want to do that. I want to factor it like usual. How do I factor that? 5 and 3 and a point. It was the difference of perfect squares. I can handle that. And now from here, I already know my 2 zeros. Yes, yes, yes. Why is number 2 harder? Okay, so you understand number 2 looks a little harder. I'm going to skip it. I'm going to skip number 2 and go to number 3. We'll come back to number 2 in just a second. If we did the exact same thing right here, if we FOIL this out, we're getting x squared minus 3x plus 3x minus 9. Can you think of something to factor that's going to end up, when you FOIL it out, giving you exactly x squared plus 9? Me either. That's why we're going to have to come back to that one, because that we can't factor it. Okay, number 3. I can factor on 3. What can I factor out? Every group can have a point. I don't know, your group keeps talking. Okay, so we factored out a 3x, we're left with this. Where are my 2 zeros? 0. Okay, perfect, perfect, perfect. Now I don't feel bad for giving you a point now. Good. I'm happy with that. And number 4, I would be super happy with, and it would be really easy if only the degree was not 4. If the degree was 2, we could rock it out really fast. However, you're smart, and we can still factor this using our perfect squares. Tell me what I should put in both sets of parentheses. 2x squared. Andrea started it off, so we're going to give her the point. Okay. That's good. Except I don't know how to factor either of those from there. It's not like I can 2x squared minus 5. It's not an easy factor. So sadly, from here, I'm going to have to set each of these equal to 0. So 2x squared plus 5 equal to 0. And I'm going to do the other one as well. 2x squared minus 5 equal to 0. And this is sad. Like, I was enjoying factoring. When we were factoring, we were knocking out the zeros so fast. And now we got to actually solve the equations. And this is where life goes wrong and people make mistakes. Okay, I'm going to do this one first. The green one. So I'll have 2x squared equals 5. X squared equals 5 over 2. How do I get rid of the squared? Okay, you can have a point for that, Landon. So my answer is x equals plus or minus the square root of 5 over 2. Do we know the square root of 5? Do we know the square root of 2? We do. No, so we're going to leave it just as it is. So if we were making a list at the bottom of our zeros, so far we've got positive 5 over 2, square root of 5 over 2, and we have negative square root of 5 over 2. One lose a point. Okay. Yay. That was not that bad. Now to do the same thing with the pink. I subtract 5, I get 2x squared equals negative 5. I divide by 2, I get x squared equals negative 5 over 2. I take the square root of both sides, I get x equals plus or minus 2 and 5, get the point. Okay, so normally we take the square root of both sides, but they were smart enough to realize, hey, negative under the radical, that's when I've got to bring out I. So I'm super impressed, because this is the first class period that immediately went straight for the I. I'm super impressed with 2 and 5 for going straight there. So we have two imaginary roots at positive square root of 5 over 2i and negative square root of 5 over 2i. I got a couple questions. One is an easy one, and one is one you won't remember, and I'll just be sad. It's okay, I've been sad all day about it. What does the I stand for? I like that. It was for the square root of negative 1, yes, but it was for us to remember imaginary. That was good. Okay. When we graph, let's pretend I put positive square root of 5 over 2 is over here. Negative square root of 5 over 2 is over here. Where do I put positive square root of 5 over 2i? Is it on the x-axis? It's not on X, Y, or Z. All those things you're naming are all real numbers, and those are imaginary numbers, so they actually doesn't cross the real number plane. So when I graph, and I know you don't have your graphing calculator, and I know I'm being extra, but I'm just extra, okay? You don't actually have, if you knew how we got here, you're done. I just am extra because I'm extra. If I graph this, because that's what our problem was, on my calculator, it only crosses twice. Why does it only cross twice? It only crosses at those two real roots. It crosses at the square root of 5 over 2 right here. It crosses at the negative square root of 5 over 2 right here. Nowhere do you see the i's on this graph. So if you have i's in your answer, that does not mean you're crossing the x-axis. They're actually not zeros then. They're just called imaginary roots. They're roots because they did solve the equation. They're not zeros because zeros implies we cross the x-axis. No. No, I'm being straight up extra. Straight up extra. Okay, number 2, I'm going to stop being extra and you're just going to help me solve. We can factor it. That's not going to happen. We're just going to solve. So x squared equals negative 9. I take the square root of both sides. X equals what? No. Plus or minus 3i. But I'm not giving you the point because you broke my heart there for a second. Okay, we got two imaginary roots, right? So, are you surprised that when I graph this one on my calculator as well, I don't actually cross the x-axis? Look, it's so sad. It goes really high. It's nowhere near the x-axis. So, you don't have to graph them. But we are supposed to be smart enough to realize if I get an I in my answer, that means I'm not crossing the x-axis. We are supposed to be that smart in life. Okay. We are brave, and we will do 5 and 6, and then I will let you work on your graphing homework that you didn't finish and you need to finish. 5 and 6 are my two favorites of the day because we're dealing with cubes. What's the acronym you were supposed to remember with cubes? 2 and 3 get a point. Okay, but before, when we were soaping it out, we did not have that number in front. So there is one tiny difference today. But we can still handle it. The same of so add a negative sign. So I'm a negative sign on here. Opposite, always positive. Now we've just got to figure out what goes in the blanks. Let's go back to the problem we did know how to do. If this was x cubed minus 27, and there wasn't an 8 in front, let's pretend there's not an 8 in front. If there wasn't an 8 in front, what would the answer be? X minus 3. X squared plus 3x plus 9. And yes, that is something you were supposed to know. Remember we put a star by it the other day in our math workshops if there was going to be a sum and difference of cubes on your next test. You were supposed to realize x to the third is x to the third. And you were supposed to realize 3 cubed is 27. So that's why we used x and 3. We did x minus 3, x squared, 3 squared, the 2 multiplied together in the middle. Woo! But sadly, that's not our problem today. Sadly, our problem has an 8 in front. That's going to be no big deal. Why is that? Tell me about 8. It's a perfect cube with 2. 3 is another point. So we're still on this kick that 3 cubed is 27. But isn't 2x cubed? 2 cubed is 8. X cubed is x cubed. So we're still doing the same thing. So I actually know how to fill this in. It's going to be 2x minus 3. 3 squared is 9. 2x times 3 is going to be 6x. 2x squared, well, I gotta think that through. 2 squared is 4, x squared. Whew. So let's think that through again, because that was deep. Are there any questions about how we got 2x? Okay, because 2 cubed is 8, and x cubed is x cubed. And then we're still doing this guy goes in this front slot. You square this guy to get this slot. So 2 squared is 4. X squared is x squared. We're still going to put the 3 in this slot. 3 squared is still 9. And the middle is still the 2 of them multiplied together. So 2x times 3 is 6x. And you're like, Miss Compton, I so wish you were done talking because that was deep. And we are not done with this problem because we need to get the zeros. We can't reduce that any. That's good to go. We can further fix this. You can. You're that good. You can. You're that good. Look at 4x squared plus 6x plus 9. Ignore the 6x. Tell me about 4 and 9. What are you supposed to know about 4 and 9? They're perfect squares. So are you surprised that I'm going to tell you it's 2x plus 3, 2x plus 3? Because if we actually fold this out, 4x squared plus 6x plus 6x, that'd be plus 12x plus 9, so that's wrong. Darn it, did this company not multiply right today? Probably not. Is that supposed to be a 12x? Dalen, love me enough and grab me that green thing. I hate it when brains go to waste. Thank you, dear. Don't you hate that when you have a brain fart? It's the worst. 3.2. Okay, since this, oh, there it is. No, I was right. I'm trying to make life too deep. I can't do that. Okay, so I wish I wrote in pencil for this moment exactly. We have been doing things right this whole time. Why am I trying to bust it up now? This was right. Now, I've rambled on too long for today. I swear to goodness we're going to finish this one and do 6 tomorrow. Have you finished your graphing homework? I've seen like 2 people. No, 3. I've seen Brady, Abigail, and Landon. Have you finished your graphing homework from the notes? The answer is no, because I've only seen Brady, Abigail, and Landon.